Welcome to Lesson 13, Add and Subtract Radical Expressions. Lesson 13 of Algebraic Concepts. So please watch the video before this one so that you can learn how to simplify radical expressions. We will have to simplify them in order to add and subtract them. Here's our objective, our vocabulary, our rules and notes, and you can always pause the video and watch them here. All right, so read over this table. Please pause this table and read over it. And here's another example of how we can add. So what I want to point out with this picture is that same letters can be added. They must be to the same power. A square root of 2 and a square root of 2 are the same thing. And we don't do anything with the root of 2. We just add the coefficients, the number in front of them. And the same thing with subtracting. X minus x. And then root, same root, can add and subtract to each other. And you only add and subtract the coefficients. The terms in front of the, or the numbers in front of the variable or root. Okay, so let's fix our root signs. Okay, again, we have a root here. So our coefficient, the number in front of the variable or the root, is 1. And so what we're going to do is put the root 5s together and the root 10s together. And the sign in front goes with it. So this is going to come down to 3 root 5 minus 1 root 5 plus 2 root 10 plus 8 root 10. And so let's simplify it on another next page. 3 root 5 minus 1 root 5 comes to 2 root 5 plus root 10, and root 10 become 10 root 10. Now, I really don't remember with roots if the lower number is supposed to go first, like in alphabetical order with variables. So I would just, or the higher one is supposed to go first. So I'm just going to leave it like this. I'm not sure how your teacher is going to ask for it or what book you have says what. Okay, let's look at our second example. So just like in the first one, the root 6s go together and the sign in front of it go with it, and the root 2s go together. So remember, same signs add. So negative 4 is negative 9 n root 6 plus, no number here, it's a number there, 4n root 2. Okay, let's look at what we have here. Let's extend the square root out, the square root out, and the square root out. All right, so what we have here is 5. What we have, 15 times 10, or 6 times 25. Because what you want to do is when you break these down, you want to look for your squares. We could have broke 150 down into 10 times 15, but you want to see if your squares, if you get your perfect squares out of it. So we have 5 times the root of 6 times the root of 25. The square root of 25 is 5. So you get 5 times root 6, which is 25 root 6, plus 12, plus 54 breaks down into root of 6 times the root of 9. 6 times 9 is 54. So you know what? Let me do one step at a time so not to confuse everybody. Because 6 times 9 is 54, I can now separate these into the square root of 6 times the square root of 9. The square root of 9 is 3, so this breaks down into 3 root 6. So plus 12 plus that, minus 6, plus 24 is, well, it's 8 times 3 works, but neither 8 nor 3 is a perfect square. 2 times 12, 12 is not a perfect square. 2 is not a perfect square. What else? 8 times 3, 2 times 12, 24 times 1, 6 times 4. Okay, 4 is a perfect square. And if we separate it, we get 4 times the root of 6. And the square root of 4 is 2. So now we have all root 6s. We got 2 constants, and then we have all root 6s. And remember, the sign in front of the number comes down. The sign in front of the number comes down. The sign in front of the number comes down. There's no sign in front of this number, so we know that that is positive. So 25 plus 3 plus 2 becomes 30 root 6. 6 minus 12, let's put a circle around it to differentiate it from the roots, becomes 6. And even though this is root 6 and this is 6, they are not the same number, so you can't add them until the square root of 6 is simplified. So that was our third example. Okay, so let's look at our next example. Okay, so what we have here is, looks crazy, but it's very simple. Okay, so r squared, 80 times 10, 4 20s. So I'm trying to think of perfect squares. All right, so you have 4 times 20, but then you have 20 breaks down into 4 times 5. 4 times 4 is 16 times 5. And see, what I'm looking for is perfect squares. The square root of 16 is 4, so you got 4r squared times the root of 5. Okay, for 45, what are we going to have? We're going to have a 1 is out here, minus 9 times 5. Now, I'm going to break this r to the 4th down into r squared times r squared so that you see what's going on. And so now, the square root of 9 is 3 times the square root of 5. The square root of r squared is r. The square root of this r squared is r. So now we have 3r squared root 5. And bring your sign down, so that's minus. Bring your sign down, so that's plus. And let's think of how to separate this one. Well, 125 is 25 times 5. And the square root of r squared is r, because the square root cancels out the exponents here. So you have the square root of 25 times the square root of 5. The square root of 25 is 5. The square root of 5 comes down, and you're left with r. So 5r root 5. Now that we simplified them, now let's look at what we have. We have r squared, r squared. So these can be combined. This is not r squared, so you cannot combine it. This is a different term. So 4 minus 3 is 1. We're left with 1r squared root 5 plus 5r root 5. You cannot do anything else. Yes, the root 5s are the same, but this is r, and that's r squared. You cannot combine a letter with the square of the same letter. They are different terms. So that looked like a lot, but what you're looking for is to break your number under the radicand symbol, your radicands, which is the number under the radical symbol, sign, the radical sign. You're looking to break those down into perfect squares. And even with the 4 times 20, I had to break it down. I did not remember that 16 times 5 was 80. So I was just looking at numbers. But then I found when I multiplied the 4 and the 4 that they gave me a perfect square. Again, r squared. So I'm just taking the square root of each one individually. So 9 is a perfect square. R is a perfect square. This R is a perfect square. That's why you got 3 and R out of it. 25 is a perfect square. And we already took the R out here, so that just stayed on the outside. And then I put it in front of the radical symbol. So your letters and your numbers that are whole numbers will go in front of your radical symbol. Okay, so those examples were a lot. So I hope they didn't look too difficult to you, but catch me at the end of the video for the recap. Okay, so here we go. Root 15, root 3, root 15, root 3. 15 is not a perfect square. You can't break 15 3 times 15. Neither one of those is a perfect square, so it's just that. So 7 minus 3 becomes 4 root 15. 15 plus 15 minus 3. Remember, the sign in front of the term goes with it. So this is plus 12 root 3. And then we're done. Okay, let's see if we have root 50, root 98, and root 2. Let's see what we can do. 50 breaks down to 25 times 2. The square root of 25 is 5, so we're left with root 2 times 3. 3 times 5 is 15 root 2. Let's see, what does 98 break down into? So 2 times 49. Oh, look, the square root of 49 is 7. So we're left with root 2 times 2. 2 times 7 is 14 root 2. Bring down your sign. Bring your sign down. Minus 1 root 2. Now that they're all root 2's, we can combine them. 15 plus 14 is 29, minus 1 is 28 root 2. And that's how you would combine it. Okay, let's see what we got. So we got the square root of 11t, the square root of 11t. So, and this looks confusing, but remember our 15t and our 7t becomes 22t. And all of this is one term, and all of this is one term. So there's a 1 here. So you got 3t minus 1t becomes plus 2t root 11t. That one is done. All right, so our last one. Let's extend that out. This looks trickier than what it is. It's really not that difficult. We just have to break it down into its component parts. Okay, so what do we have? 2 times 121. The square root of 121 is 11 times the square root of 2 times 4y becomes 44y root 2. Bring your 3 down. Let's see. Y to the 6. If I do y to the 6, I got y squared times y squared times y squared. And the square root cancels those out. And we got 9 times 2. 3. The square root of 9 is 3. Root 2 is root 2. And then y squared, y squared, y squared. The square root cancels out all of them. And so I'm left with y times y times y. So I get 9y cubed root 2. Y times 50, that's 25 times 2. Y times 5 times the root of 2 becomes 5y root 2. Bring your sign down. Bring your sign down. 32 breaks off into 16 and 2. And we saw how the y6 broke down into y cubed. So, times y to the 6. So I'm just going to bring it there. 5, the square root of 16 is 4. Root 2, y cubed. So you get 20 y cubed root 2. Okay, now that it's all lined up, let's see what we have that's alike. We got 2y cubes minus y cubed plus 9y cubed, and we have 2y's plus 5y and 44y. Okay, our y cubes are higher, so they're going to be written first. And 9 minus 20 becomes negative 11. Negative 11 y cubed root 2 plus 44 plus 5 is 49 y root 2. Now, you cannot combine a y cubed and a y, so that makes them different terms. We're done. It's simplified. You can't do anything else. So there was a lot in this video. We had to simplify, and we had to get the radicals to be the same. We had to make the letters the same. So I hope that this video was helpful to you guys working on adding and subtracting radicals. I may have to make a video on putting numbers under the radical sign. We just went backwards, but maybe we had to go the other way. So, like, subscribe, share if you like what you saw. Thank you for watching this video.